Back. This is Mr. Hassan's Maths channel, and I'm now going to be answering a question from one of the end of topic worksheets I have for my Cambridge collection about momentum. Now, this question is taken from another examining board called OCR from the UK, and the reason I've chosen this particular examining board to take this question from is because momentum is a new topic in Cambridge. It only introduced in 2020, so there's not that many questions on it that you'll find in the past papers. And the later past papers I like to leave for the students to do by themselves, like as practice before their exam. So I've decided to take questions from another examining board, which have questions which are kind of similar to the momentum questions you find in Cambridge. The ones from Edexcel are not so similar. They're more about momentum and impulse, and they're not as similar as these questions. So I've chosen some questions from this board so that I can give questions which are similar to the style of questions you might find in a Cambridge momentum question for M1. So this is question number 4 from this particular paper, and number 4 from my worksheet as well. And here we're told about 4 particles A, B, C, and D, which are on the same straight line on a smooth horizontal table. So there's no friction or anything like this. A has a speed of 6 meters per second and is moving towards B. B has a speed of 2 meters per second and is moving towards A. The particle C is moving with speed 5 meters per second away from B and towards D, which is stationary. So D is not moving, it's stationary. Okay, the first collision is between A and B, which have masses of 0.8 kilograms and 0.2 kilograms respectively. After the particles collide, A has a speed of 4 meters per second, and it's in its original direction of motion. Calculate the speed of B after the collision. Okay, so now what I'm going to do is I'm going to, as I always like to do, although there's a diagram drawn, I'll draw my own diagram. I'm going to have A, which is, I've got a mass of as I told us, 0.8 kilograms. We have B, which has a mass of 0.2 kilograms. We know that before the collision, A is moving towards B with a speed of 6 meters per second. B is moving towards A with a speed of 2 meters per second. After the collision, they told us A has a speed 4 meters per second in its original direction, so in that same direction, 4. And B, we have to find what its speed is after the collision, right? So what I'm going to do is I'm going to take the convention, I'm going to take the right as positive. I don't have to. It's up to you what you take as positive, but I'll take the right as positive in this case. So that's very important here because a lot of people mess up with their signs in these type of questions. So you have to make sure you do the right thing in terms of taking the, one side as positive and going by that for your velocities. So now we know that before the collision, this was the situation. And after the collision, this is the situation. And we know that with momentum, we know momentum is equal to mass times velocity. So the momentum is equal to the mass times the velocity, right? So the total linear momentum before the collision and after the collision in the whole system must always remain the same. So if I find the mass and velocity of A and the mass and velocity of B before the collision, it must give me the same value as the mass times the velocity, the momentum of A and the momentum of B after the collision. So what I'm going to do is I'm going to set an equation here. I'll say, okay, before the collision, A's got a momentum of 0.8 times 6. 6 is positive because we're taking right as positive in our diagram. And B has a momentum of 0.2, its mass times its velocity. Now, its velocity is in the opposite direction to what we call positive, so I'm going to call that negative 2. And that's equal to the total momentum after the collision, which is going to be for A, 0.8 times positive 4, and for B, it's 0.2 times what we have to find. Okay, so the only unknown is what we're trying to find, the velocity of B. So this gives us 4.8 minus 0.4 equals 3.2 plus 0.2 times the velocity of B, and that will give us our answer. That's 4.4. But I can do this in one step. I have 4.4 minus 3.2 equals 0.2 times the velocity of B. That gives us 1.2 equals 0.2 times the velocity of B. And we have to divide both sides by 0.2. So we can say the velocity of B is going to be equal to 1.2 over 0.2, which is going to be 6 meters per second. Okay, so we can say the speed, they want the speed, just write speed equals 6 meters per second, right? So we know that it's going in the same direction as we call positive. So B has had its direction reversed. Of course, it has to have been because A is moving this direction. But the question didn't ask us about anything about the direction. So we can just leave it as speed equals 6 meters per second. If they ask about the direction, we can say its speed has been reversed. Or so its direction has been reversed, sorry. Okay, so there we have the answer to part 1. Now for part 2, it says the second collision is between C and D, which have masses of 0.3 kilograms and 0.1 kilograms respectively. Now we know that C was moving at 5 and D was stationary, as they told us. All right, the particles coalesce. The particles coalesce when they collide, which means they join together as one particle. Right? So find the speed of the combined particle after the collision. All right, so now let's look at what's happening before. Now, before they're two separate particles, so I'll draw them as two separate particles. You have C has a mass of 0.3, as they told us, kilograms, and D has a mass of 0.1 kilogram. So there's C and there's D. Now, after this is before, okay, and let me just put the speed. C is going this direction, 5 meters per second, and D is not moving, 0 meters per second. Now, after the collision, it's slightly different. Now, it's like they're one big particle. So I'll draw them as one big particle with a combined mass of 0.4 kilograms. Okay, because this is like 0.3 plus 0.1 equals 0.4. So that's a combined mass. All right, and they have, of course, going with one single velocity, which I'm not going to put the direction, although it's pretty obvious it's going that direction. I'll just put V. Right, so we need to find what this V is. All right, so again, we use the same principle. The total momentum before and after must be the same. So before the collision, we have 0.3, and again, we'll take this direction as positive. So we have 0.3 times 5 plus 0.1 times 0, it's velocity 0, equals 0.4 times V. And that will give us our answer. So that gives us 1.5 plus 0, so it's 1.5 equals 0.4 V. So you have 1.5 divided by 0.4, and that gives us our answer. And so that gives us, if you do 1.5 divided by 0.4, that gives us 3.75 meters per second. Okay, so let's have a look, just to make sure. 1.5 over 0.4, 3.75 meters per second. So there's the answer to this question. So we can say that the speed after the collision is 3.75 meters per second. Okay, so there's the answer to part B. All right, part 2, sorry. Now for part 3. Part 3, and this is the question, or part of the question I think the students had some issues with. So it says the third collision is between B and the combined particle. Okay, so if we just modify this, this is the diagram of what's happened or what was happening initially. Now we've got a different situation now. So I'm going to modify this little diagram they gave us to illustrate what's going on. So now we don't have C and D separate. The C and D are one particle. So I'll just get rid of this D. Okay, and we have, these are changed now. Okay, because this is after A and B collided. So after A and B collided, A was going at a speed of 4 meters per second this way. And after B and C, B and the combined C and D, this is C plus D, after they collided, B was going at a speed of 6 meters per second this way. And this was going at a speed of, after C and D collided, sorry, this was going 3.75. So after A and B collided, B was going this way, 6 meters per second, A was going this way, 4 meters per second. That's after A and B collided. After C and D collided, they combined together as one object, and they were going at 3.75 meters per second in this direction. Right? That's C and D together. Right? So now what's going to happen is B is going to collide with this. So let's do a little diagram for that. So B has got a mass of 0.2, I think it was. Yep, 0.2 kilograms. Okay, and C and D together have a combined mass, if you remember, 0.4, 0.1 plus 0.3, something like that, 0.4 kilograms. So that's B, and that's C plus D together as one particle. Before this new collision, B is going to be moving at 6 meters per second this way, and these combined is 3.75 meters per second this way. Now, we want to find the greatest possible speed of the combined particles. We want to find the velocity of C plus D after the collision. All right. Okay, so now how do we work this out? They didn't tell us what the speed of B is, so we got to think a little bit. Now, it says the third collision is between B and the combined particle, after which no further collisions occur. Right, so this is a smooth table. So, I mean, if there was no collisions going to happen afterwards, then basically B is going to be moving off at the speed that it's going to reach after the collision, all right? And A is going to continue moving at 4 meters per second this way. So A is moving at 4 meters per second this way. At the moment, B is going further and further away from A as time goes on. But then it collides with C and D. A is still moving at 4 meters per second. Now, if the speed of B becomes less than 4, then A and B will collide, because A is going to be moving at 4, B will be moving at less than 4. Eventually, they'll collide again, and this will not be true anymore. There will be a further collision, right? So for there to be no further collisions at all in this situation, the velocity of B, okay, so for no collision, you can say the velocity of B after the next collision takes place, this one, has to be greater than or equal to 4. If it's equal to 4, then A hasn't caught up with B yet. They're both moving at the same speed. A will never catch up with B because they're going at the same speed. If it's greater than 4, it's going to be moving further away from A as time goes on, so there'll be no collision. But if it's less than 4, then A will catch up with B. So that's why we have to be very careful in this situation here, all right? And we have to realize that the minimum speed of B is 4. Now, why do we care about the minimum speed of B? They're asking us for the greatest possible speed of the combined particle. Now, hopefully, when we set up the equation for this, you will understand. So I'll leave this as VB for now. So let's look at the total momentum before the collision. It's going to be 0.2, which is the mass of B, times 6, plus, and for this is going to be 0.4 times 3.75. They're both going in our positive direction, which we call positive. And after the collision, you have 0.2 times VB plus 0.4 times V that we're trying to find, C plus D together. Now, basically what's going to happen is these two you're going to add together. So we'll find out what that gives us. You're going to have 0.2 times 6 plus 0.4 times 3.75. Okay, that gives us 2.7. So you have 2.7. Okay, and you're going to have minus 0.2 times VB is equal to 0.4 times V, C and D, which we're trying to find. Now, you see, the velocity of C and D together at the end will be the biggest possible value if the velocity of B is as small as possible, because you're going to have 2.7 minus 0.2 times the velocity of B. So if the velocity of B is bigger, this total side will become less, and then your velocity of C and D will be less. So the smaller that the velocity of B is going to have a value for, the bigger the whole of this side will be, and the higher velocity of C will be. But we know that the velocity of B, it has to be greater than or equal to 4. It can't be less than this. Otherwise, there will be a further collision, as we just discussed. So therefore, we're going to use the smallest possible value of V. The velocity of B, the minimum velocity of B has to be equal to 4. Otherwise, there will be another collision. So we have to use a minimum value of B to give us a maximum value of C. C plus D together. So you have 2.7 minus 0.2 times 4 equals 0.4 times the velocity of C. So we'll work what that is now. So we have 2.7 minus 0.2 times 4, which gives us 1.9. So you have 1.9 equals 0.4 VC. So the velocity of C and D together is going to be 1.9 divided by 0.4. So this will be our answer, divided by 0.4, which gives us 19 over 4, which is 4.75. Okay, so that gives you 4.75 meters per second, and there's the answer. Okay, they didn't ask us about directions or anything like that. So there's the other answer. Of course, it has to be towards this direction, otherwise there'll be more collisions. So basically, this is the question that people had problems with. Okay, and hopefully you understand that as long as after this next collision, B is going either 4 or more than 4, then this will hold true. There will be no further collisions. If B's velocity is reduced to less than 4 after the collision, then A eventually will collide with B again, because they're going to be moving at that speed after that. Because it's a smooth table, there's no friction, they'll continue going with that same speed after that collision. So if B's speed is less than A, A will catch up with B, and there will be a further collision. So for no further collisions, B has to be going either at the same speed as A or greater than it, then A won't be able to catch up with it. Okay, so hopefully that was clear. Thank you for watching. Other questions from this particular paper, this OCR paper, I don't know if I'll answer any other questions from this, to be honest, but I'll make a playlist anyway in case I do, and I'll place this question in the playlist over here. Other questions from this worksheet, if I do answer them, will be in the playlist that will appear in this region. You just click on that link, and at the end of the video here, you'll see a playlist for my questions from Cambridge, momentum questions in general, which will be over here. And you can click this link here to subscribe to my channel if you haven't already done so. And the card at the top of the video will take you to another video which explains to you how to use my channel to find the material that you might be interested in. Looking at IGCSE, Cambridge, EdXL, whichever board you're trying, wherever I have, you'll be able to find how to find it there. Thank you for watching, and see you soon.